Hello, this short video is intended as a quick tutorial for 6th grade science fair students. I am Latonya Bernard and I'm the Program Director of Middle School Science. Thanks for viewing this short video and I hope it answers questions you may have about helping your child to be successful in preparing a science fair project this year. We expect all students to be successful and encourage their inquiry as they learn the nature of science. Last year, two of our middle school students, pictured with their teachers, advanced to the state competition in San Antonio, Texas, and were nominated to compete in the National Science Fair competition for middle school known as Broadcom Masters. The students pictured received place or special awards at the Science and Engineering Fair of Houston, which included advancement to other fairs and/or money and recognition. We are adding the 6th grade fair to allow younger students exposure to competitive science experiences. So they are ready for the 7th and 8th grade fair next school year, where they may advance to regional, state, and national fairs. So, what is a science fair? A science fair is a journey of scientific inquiry. Students answer a scientific question by conducting an experiment. The process ends with a showcase event that shows students that their work matters to the school community and the science community. There are many benefits for students participating in the science fair. They have the inquiry and experiential experiences. This is their own learning adventure. There are many topics for students to investigate. Some ideas can be found by simply Googling science fair. The best projects are the ones students develop from their own questions about the world around them. Science fair also is an opportunity to apply what students have learned from all other contents. This includes mathematics, technology, research, which might be done in their reading class or history, writing, and presentations. The school science fair is the first step in the competitions that lead up to the international level, where prizes total over $3 million and the top winners take home thousands in scholarships. Preparing a science fair project is an excellent example of what education experts call active learning or inquiry. We also call it hands on learning. It is a very effective instructional method. Indeed, it is recommended as a cornerstone of successful science teaching. In Texas, middle schools students are required to participate in 40% inquiry-based instruction. For the science fair, teachers and parents work together to help students advance and learn the scientific process. Our planning involves breaking the science project into small, manageable assignments that are spread out over time. The students were provided a guide with checkpoints to help them manage their time and prepare their projects. So, what do the students need to do? Students need to follow the scientific method or the engineering design process. In this video, we will look at the scientific method. There are 6 parts or steps the students should follow. They should ask a question, do background research, construct a hypothesis, test the hypothesis by planning and doing an experiment, analyze the data and draw conclusions, and then communicate their results on the science fair day with their display board notes and their presentations. Avoiding a shaky foundation, at this point, each student will fill out a project proposal, which is a roadmap of where they plan to head. It is critical for the teacher to evaluate each student's question so that the students can redo their questions at a point when they can start over. The question is the foundation of the experimentation that is to come. Some tools and techniques that might be considered very safe can become unsafe without supervision and a careful experimental procedure. Some potentially dangerous materials can be perfectly safe with the right supervision and the right experimental procedure. Teachers will evaluate safety on a case by case basis. If you, as a parent, have any expertise in supervising certain tools or techniques, then by all means help your child to note this on the proposal form. With your supervision, the child will then likely be able to do the project. Also, if you know someone in a science field that works in a particular area and they're able to assist your child with their project, that would also be acceptable. So, there are some rules for picking a good question. So, how to pick a good question? The question should be interesting enough for your child to read about it and research it and then work on it for several months so that the student doesn't lose interest in the project before it's over. There should be at least three sources of written information on the subject. So that's where they're doing their research. If they find articles online, if they're using books from the library, they need to cite those sources so that we know that they have actually researched the topic. Want to make sure that the experiment is safe to perform um, and ensure there's enough time to do the experiment before the science fair. Science fair projects don't go well when they're rushed at the last minute. So we want to really make sure we stick to a plan to grow the project over time. Here's a helpful resource to find a great project idea. ScienceFairBuddies.org is an excellent website for not only finding an idea, but also developing your idea and the project that you're working on, as well as tutorials for each individual part of the scientific process. You want to do background research. Collect information, define what to look for, look in a variety of sources. You want to have enough background information so that when the judges ask questions, you're able to answer them. You want to organize your research information. Again, we always want to cite where the information comes from. At all times, we want to avoid plagiarism. Want to make sure that all writing, when we do the report in the end, that it focuses on the project. Next, we'll construct a hypothesis. A hypothesis is a prediction to the answer of what the question will be. So, whatever your question is, you want to predict what you will find once you do the actual project. So it's a if and then statement. If I do this, then this is what's going to happen. So if I increase the temperature of water in a cup, then more sugar will dissolve. When we test the hypothesis, it is very important to plan the design and the procedures in steps, step by step, what you're going to do, what are you going to use, and how you're going to do it. What's your time frame for doing it? And then actually do the experiment based on the steps that were presented. It is okay if the experiment goes wrong and your child has to modify the procedure. However, everything the students do and the results observed should be added to the project notebook or journal. If they have to change the procedures, this should also be noted in the journal. So all observations should be included in the journal. A lot of things that we use today were actually discovered by accident because scientists did the wrong thing, but they kept copies and notes of what they'd done. For example, Kevlar that is used by police in their protective vests was actually created by accident. The scientist wasn't trying to do that, but she documented everything she'd done and was able to recreate it. And now many lives are saved because of that accident. It's okay if the experiment disproves the hypothesis. We don't want to go back and change the hypothesis because it was wrong. We just want to state that it was wrong and state what actually happened. Of course, we want to always be safe, and also it takes time to do this. So take time and actually work through it and analyze and document everything. Next, we want to analyze data and draw conclusions. So, as data is collected, are two different things. Things that you notice, if you see, smell, hear, feel. I don't recommend tasting. Please don't taste unless it's a safe environment. It's something that's safe to do and with parental permission. But that should be documented in their notes in the journal. But also, if they're collecting data, numerical data such as speed, temperature, time, etc., then that should be recorded in data tables. The data tables should then be converted into graphs to show where it's been analyzed. Then finally, we're going to communicate our results. This is where we actually get to the science fair itself. It's presenting the science fair project in a way that people working in the science field are able to see how the science was done, how the student investigated, and then implemented the information from their investigation in an actual experiment. There is a certain way for things to be put on the display board. This particular image came from sciencebuddies.org, which is highly recommended as a resource site for students. Topics to avoid. Some projects that are commonly shown in movies and commercials are not considered quality projects for the purpose of competition. They're often used in movies and commercials because there's a big reaction. And that's what, in cinematography, that's what they need. It's something that's going to be a big reaction. Volcano models, while acceptable, are not normally winners because the process used in creating the volcano for the project doesn't actually demonstrate what causes volcanoes to occur. They're not actually showing how the Earth's plates are colliding and subducting and making the heat and pressure that cause the volcano. So volcano models are not really practical science fair projects. Likewise, solar system models are not practical science fair projects because they're not going to demonstrate the gravitational pulls that actually cause planetary rotations and revolutions. The goal of the science fair project should be to add to the body of scientific knowledge to expand on what was already discovered. So even if students find a science fair project online, they should still look at what can they do differently or add to that project to make it go further than the original person did. The Houston Academy Science and Engineering Fair will be held on December 14, 2018 at the Houston Academy Library. During the judging phase, parents should not be on the exhibit hall floor because we do want the students to be able to present independently without coaching. So the fair itself will be throughout the day. The projects will be judged in the library at Houston Academy. The Aldine ISD Middle School Science and Engineering Fair will be held on Saturday, January 12th, 2019, from 8 o'clock a.m. to 5 o'clock p.m. at Meade Middle School. The competitions include the science fair, where students display their projects and actually defend their project topics and their research. Um, It's also going to be a pick fair in which students can do a digital photography photo and write a paper about the science that's involved in that particular photo. For the DIMSA Pick Fair, the student has the projects are selected from the campus fair, just like with the science fair projects. For example, in this picture of an amaryllis lily, some of the science that's involved would be the pigmentation that is shown, as in the color of the flower, why we can see certain colors and why we don't see other colors, or even something about the pollination, showing that where the pollen is, where it's located, how it goes from this flower to another flower, and so on. We also have a Science Bowl competition where a team of only 2 students per campus per grade level is selected to complete an assessment, and the campuses with the highest combined scores win the medals and awards for Science Bowl. New this year will be a vocabulary challenge based on vocabulary.com, in which students even now can log into vocabulary.com and do vocabulary quizzes for points. This is actually an international competition. We're going to do it with just our campuses, and the campus with the highest average points based on the number of students on that campus will receive a banner for the vocabulary challenge. Aldine ISD Middle School Science and Engineering Fair categories. The regional, state, and national fairs use these categories for science projects. A student can do one project in any of these categories to compete on each level. For our fair, to sixth grade cannot be promoted up to the regional and state fair, and because some topics need a scientist in the field to actually approve it, we're not allowing sixth grade students to do animal science, medicine and health, and biochemistry and microbiology unless their parents or someone they know works in that field and is going to coach them through their project. All science fair projects for the district fair are judged by a panel of 3 judges from the science community, including teachers, scientists, and administrators. During the interview, the teachers question the students to determine their comprehension of the science in their projects and ensure that all students in group projects are equal participants, that all of them have equally done a portion of the work and that they all understand the science. Judges also give advice to improve projects so that students who might advance to the next level or might decide to work on the same project for the next school year have some information to help guide them along the way. The science fair resources and rules. More information concerning project selection and rules may be found at the Science and Engineering Fair of Houston website, or you can Google SEFH and find information there. There are also links to other websites within the Science and Engineering Fair website that will also have information to help you and your students with preparing their projects. One of the sites that is really beneficial for students is the sciencebuddies.org website. It has a project idea generator where the students can actually go through the wizard and answer questions to find projects that are topics that they or might be interested in. They can also browse by topic or by grade level. If the student has a topic that they're really interested in and might want to move forward with that same project over the next couple of years, they might want to look at a project from the 7th or 8th grade so that they can keep working with it and build it forward. Because as long as they are adding to the project and extending it, they can keep entering the same topic and the same category, but each year they have to show where they've advanced their research. There's also a project guide where students can look for information for each individual part. For example, the bibliography, which is where they would cite information on their project so they can find out about what information they can cite. It also gives some ideas about where they can go, like going to an encyclopedia or a dictionary to find information. Well, you want to say where you found that information. There's some examples of things, APA format, for example, MLA formatting, um, various topics, things that you can use to help your student. There's also an ask an expert, where if there's a question, you can actually submit your question and someone can, the site itself will see if they can find someone to respond. Students can explore careers and then do a project based on the science career they may be interested in. What I love about this particular site is that there is a parent portal, and so there's a parent area where you can find information to assist you while assisting your student, as well as a page for students where they can get additional information about activities, science fair help. There's even a section for students that are advanced. So I hope this information has been beneficial for you. And of course, if you need additional information or if you want to ask questions, feel free to email me. That's the easiest way to reach me is by email. I am Latanya Bernard. I'm the program director of middle school science, and I can be reached at lcbernard@aldeanisd.org. And just remember, science of today is the technology of tomorrow. Edward Teller.